Hello everyone, I'm Alfian and today we are going to solve the LeetCode challenge on the challenge number 112 called the path sum. And for this particular challenge, given the root of a binary tree and integer target sum, return true if the tree has a root to leaf path that such adding up to all the values along the path equals to the target sum. And a leaf is a node with no children. So a leaf, I want to point out the leaf that this is the binary tree, and a leaf is considered the end of a tree of the branch without any root, without any node left and right property. So the one that is considered the leaf path, which is this one, and then this one without any further property, let's say left and right property, and also this one, and finally this one. And those are the leaf nodes without the left and right property. So if there is at least one either right or left property, like this one, which is node 4 right here, it's still considered not a leaf and it's still considered a branch. And we need to declare an answer. It will return true only if it is starting from the root to leaf, which is from the 5, which is the root, and at least connecting one of the either left or right property or left or right node. So that is considered a whole answer of the true. And we have the input of the 5, 4, 8, 11, 13, 4, 7, 2, and 1. And the parameter, second parameter, which is the target sum, which is 22. So we need to, let's say, traverse over the binary tree or all of the branches to see which end that leads to the number 22. Let's say from this part, 5 added by 4 equals to 9, added by 11 equals to 20, and then finally traversing over this part added by 22, which is equals to the 22. And so this part from the whole binary tree is considered true because there is an answer leading from the top or the root to the leaf branch, from the root, which is node 5, and the leaf branch, the leaf node, which is 2. And since 5 is already reaching on the node 11 right here, which has the current value of 20, we have 20 right here on this state. If we go over the using the recursion to the node 7, which equals to the 27, and this is not the answer that we are looking for. And if we traverse over the 5 with 8 equals to the 13, and then 13 to the left side added by 13 equals to 26, and 26 is not the answer from the leaf. Let's say if we are going to the right property to leading to the leaf 1 right here, traversing from the root node, which is 5, and we have 13 right here on the 8, and traversing over the node 4 we have 17, and finally to the node 1, which is 18. And 18 is not the answer that we are looking for because the target sum is 22. So this part is correct one, and we have the output of true from all of the calculation. Then we need to return early from our recursion call or traversing over the node once it found the real answer from any of the leaf provided right here, branching from the root. So we don't have to calculate or traversing over the rest of the nodes once it has been completed or found one. And explanation, the root to leaf path with the target sum is shown from as the blue nodes right here, blue node chain. And for the example number 2 right here, we have the root which is 1, 2, and 3, and the target sum is 5. If you look over the root to node, which is 1, 2 with 2, we have the value of 3, and 1 with 3 we have value of 4. There is no target sum of 5, so the output is returning to false. And we have the final example right here, which is root null root without any root at all, and we are returning false because even the target sum is 0, but there is no root to leaf connection, like at least two nodes connecting each other as the parent and child, and the output is false even though the target sum is already 0, because since the tree is empty, there are no root to leaf path or connection. Okay, so without further ado, let's solve this out by creating we are using the BFS of roots, but first I'm going to show you using the DFS, or the starting from the last in first out principle, by creating a array using the constant of the array called the stack, and we are creating the stack of empty array like this, and we need to add the type of the root using the root. Then we can fill it using the tree node class, custom class that we already declared from the top right here, the definition of the tree node. And I forgot to mention that we are filling the function of the hash path sum, and we are completing this function, and we are using the TypeScript as our language. If you want to use something else other than TypeScript, then go ahead, and encourage you to do so, which takes two parameters. The first one, which is root and either tree node or null data type, and the second parameter, which is the target sum, which is in a form of integer or number, and the expected output is in a form of boolean, either true or false. So since it is expecting a boolean, then we need to return false for now. And then from this stack right here that we are working, let's say from the stack that we are creating a stack of root, and then finally the root dot left, which is the node 4 right here, 4, and then another 8, and then we need to process over the root part, process this part, and we are after we processing this part, and we are left with the 4 and 8. Check, and since it is already in the stack 4 and 8, 4 already has 11, then we add 11 to the stack, and we are adding 13 to the stack, and we are adding 4 to the stack, because from the left and right property of the node 8 right here. And then we process 4, we are removing 4 and 8 because we already got the 11, 13 and 4. Then 11 will be processed, and then 11 will be removed, and then we got 11 will yield the value of 7 inserted into the current stack is 13, 7, and then 2. And we are using the 13, since 13 is a leaf, then we need something to show the current state of the calculation from the top or from the root to the leaf. Then we need to carry one more data, which is another value or another number, and we declare this as two-dimensional array. Declare this as two-dimensional array, and we are declaring empty array for now. So from the node 13 right here, we are carrying the value of 13 with the 5, 8 with the current value of also 13. With 13 is added by another 13, and check if the calculation is equals to the target sum. Since it is not, then it will be removed from the processing stack right here. Then we are processing the node 4, 7 and 2, and 4 is being processed and 4 is being removed, and 4 will yield the number of 1, which is on the right property, and left property is null. Then we are processing 7, since 7 is considered leaf. Then 7 checks from the 5, 4 and 11, we have the value of 20, which is the second data type from the 7 right here, and 20 with 7 added by the 7 itself, and we got 27. Check if it is considered the target sum. Since it is not, then it will be removed from the stack. Then we need to process 2, and 2 has the value of the 20 with 2, 20 with 2, then of course it is equals to 22, because it is from the right side of the two-dimensional array, which is on the index 1. Since 22 is the correct answer of the target sum, then it will return true. Then we got the answer that we are looking for. So that is the function of using this stack, using the LeetCode principle. LeetCode, which means that last in first out. Last in, anything that first place will be placed on the last part of the or the end of the array, and first out, which is on the first node, the one that is already on the bottom of the stack. So that is the last in first out principle, and using the DFS approach. Okay, so next one, we need to use the while loop. While, as long as the stack is not empty, while stack length is above the number 0, then we need to process the stack. But before that, we need to declare the stack not to be empty, because we need to run the while loop for the first time, or the initialization. Then we need to store the first value of the stack using the root itself, passing the parameter of the root, which is in the form of class tree node right here. And the second data type of the number, we need to pass in the target sum subtracted by the root.data, and that way we got the initial value of 5 with the 22 subtracted by 5, which is equals to the 11, and we got 5 and 11 into the stack. And we need to destructure the stack, process the 5 and 17 using the constant of the current node, and then the remainder, which is the 17 right here. And we need to process this part of the stack using the stack.shift. A shift method is going to remove the first element from the array and returning the value as the destructured one right here, which is the node variable as the 5 and remainder as the 17 separately. So that is the destructuration technique. And for the next one, we need to check if the remainder is strictly equals to 0, and also we need to check if it's not the only node, which is the root node, and it is chained with at least one node. So we need to at least chain if using the ampersand sign, double ampersand signs, check if the node, not passing the root but the node dot left, because node is already destructured from the node 5 right here from the tree node class. Node left is not null, node left is already null, and also the right part, node dot right, is also already null. If it is, then we need to return true. Why we should check for the node left and node right to be null is because we need to determine if the node from the state that we are currently working on is already at the leaf or not. It is representing if we are already in the leaf node or not, when checking if the left and right property is already null. So this one is important in order to return the answer of the true. After we process the remainder, we need to check if the node.left is exists. Then we need to assign new node. If this first if check already returning false, or it is not suitable yet from the if check right here, then we need to process. Then there is another branch of the node. Then we need to assign node to the current stack of the node left using the stack.push, and we need to push inserting the node left into the current stack, which is placing at the end of the array like this. Using the stack.push, we are inserting the node, passing the node.left. Don't forget to use the square brackets, because using the push right here, we are taking only one parameter, but this parameter is in the form of array, two-dimensional array. Then we are passing the node.left in the form of array, and for the second element, which is the remainder, subtracted by the node.left.value. And this is for the first one. We are not supposed to pass in the root.data, because the class tree node is in a form of value, property value, and property left and property right. So the root.data is irrelevant. So we are passing the root.value instead, because it's in a form of number. And for the next one, we need to pass in if the node.right is exists. Then we need to stack push, inserting the node.right also into the stack to be processed inside the while loop right here. And we are passing the node.right and passing the second element of the array that has the parameter is in the remainder, subtracted by the node.right.value. And finally, we are returning false. So let's run the code to see if it works. And we have the root.value cannot read properties of null, reading value. And for the last executed input, which is on the example number 3 right here, input of the empty root or the empty root parameter right here, which is stating as the null from this particular test case, and the target sum is 0. Then we need to add an edge case to check if the root is already empty or root is null. Then we need to return false. Okay, so let's run the code again to see if it works. And we have the correct answer, accepted answer. How about we submit this code? And we have runtime of 9 milliseconds. Why? Is because we are using the LeetCode principle or depth first search. I don't know if it's depth first search or breadth first search. Correct me if I'm wrong. Because we are using the stack shift as in first out principle, and we are removing the array on the first element one at a time and then process from the stack. What about we are using the first in first out principle? What it means by first in and first out principle? Let's say we are adding a new array, new one-dimensional array at the end of the array stack. Then the first in first out, since it is first in and first out, then first out will, after we use it, the inserting the new array into the end of the stack, then it will be processed on the while loop using this destructurization technique, and we are removing instead of removing the first element of the array, then we are removing the last element from the array. We just added from the stack.push method right here from the either left or right or both, and we are removing the array element that we just inserted right away. So that is the first in and first out principle from the stack. Instead of using the stack.shift, we are using the stack.pop, and that way we are removing that we already created the array. We are removing the already created array from the current stack from the end of the array instead from the first element of the array. So let's run this again to see if it works using the first and first out principle. Let's see the difference. And we have 6 milliseconds. Okay, so that's about it. I hope you understand my explanation. Oops, it is 1 millisecond now. Okay, so that's about it. I hope you understand my explanation. If you have any questions regarding this challenge, or if you have any better solutions regarding this challenge, also tell us what you think in the comment section. I hope you have a great day. Thank you for watching the video, and I will see you in the next video. Goodbye.